Welcome to Using Scale Models. I'm Jason, your host, and I do models. We are looking at this Nintendo Switch again here. I got it taken out of the motherboard taken out of the case, and I'll show you under the microscope. It has flux residue around the USB-C connector. It appears that this battery management chip has been replaced or attempted to be replaced. These caps have been moved, and the back of the board looks fine. It doesn't look like any work was done on the back of the board, other than these poor solder jobs on this connector. So I'm not 100% convinced that this connector's good, so I'm going to replace that in a bit. But I stumbled across something on this side by this battery management IC, and I want to share that with you. But first thing I did was I checked for shorted capacitors. So let's go in here and let's make that big. Can I bring in this? Hold on a minute. There we go. I can bring that in. So I'm going to turn on the meter and I'm going to put it in continuity mode. So right now it's an open line. I touch the probes and I get an ohm reading. I could do this in diode mode, but I'm in continuity mode. So I'm going to come over here. Well, first let's start up here with this this chip right here, the charge control chip. So I checked all these capacitors here. I put one probe on ground. That side's ground. That side's not grounded. So I went through and I checked all the capacitors. So none of these are grounded. I checked all these up here. I didn't want to waste time on camera with that. So I came down here to this battery management IC right here, and I checked, that one's good. That one's not shorted. That one's not shorted there either. So shows an open line and all that stuff. So I checked it all and I'm like, oh man, they floated a new battery management IC. This cap has been moved at a position, this cap's been moved at a position, and this USB-C port is not the best soldering job I've seen. So I'm not sure where to start, and I was like, I want to check the ESR value of these capacitors over here. So I checked them all because I was just killing time while my son was in school and I wanted to play with the tweezers. So let me take you out of, let me do this and this. So here are the ESR tweezers here. I'll take the meter off the screen. Here's the tweezers. You turn them on and you just grab something and you get an automatic reading. But what I'm going to do is I'm going to set my mode to resistance, and if I come in here and if I measure one of these capacitors here, hopefully you can see that, you get like, that's not working right. If I measure one of them, that's 1.7 ohms. Okay. That's 900 meg ohms. And then this one right here was also 1.28 ohms. So all the capacitors on the board are 1 meg ohm in series resistance. I thought I checked this. Yeah, that one's a meg. So it was 1 meg. But this one right here, for some odd reason, it measures 1.2 ohms. I've looked at the traces where they go, on the back of the board. It's hard to tell what that's connected to, but it looks like a input capacitor for the battery management IC. So instead of floating that battery management IC, because I haven't floated chips in a while, I'm going to pull that capacitor off and check it. So that's my next goal on this part, is to pull this capacitor off and check it, because from my knowledge this should be meg ohms of ESR, not 1.2 ohms. But see, there's not a short to ground, so I'm not sure if that is on the cusp of going bad, and I'm not sure if it is this USB-C connector that was put on incorrectly. So before I go checking this USB-C connector, I am going to check this capacitor, because that's pretty easy to check, and then I'm going to check the USB-C. I might hook up power to this USB-C and see what happens. But the connector's new. You can tell the connector's new. And it also, it makes me wonder what's going on with this, that it wasn't an easy fix, because it had a brand new battery in it that appears to be good. It had a brand new USB-C connector and a brand new battery management chip, and it still doesn't work. So either those three things were, replaced incorrectly. Either those were replaced incorrectly, or, there's more going wrong with this. But, the chip, other than it had a bunch of flux around it, it doesn't look too bad the way it was put down. It looked like it was put down by someone that knows what they're doing. I mean, like I said, they did nudge some components over here, but that's not a big deal. I am concerned about the USB-C connector. It's not the best soldering I've seen. I'm hoping they used leaded solder and didn't pull up any of the pads when they took the old one off. So I may take that off just to see. As you can see here, there you go. You can see let's make that bigger. You can see not the best solder joints in the back and up front there. They're alright, but it's not my standard. And you see the pins down there. I don't know if I can get a probe inside there, can I? Might be able to test those pins, because they should. No, I think I'm hitting the ground plane. How can I see if I'm getting down there to touch those pins? It's got the 3D microscope function here. Yeah, I am touching those pins. So I could check to see if there's continuity here. It's not something I can do on camera, but I could check to make sure everything's connected on that USB-C before I pull anything off this board. But, the filters are all good. I checked all the filters, I've worked on electronics before. I've never worked on, a Nintendo Switch before. I, did a screen, changed a battery, things like that. That's no big deal. Changed the joysticks and a Joy-Con. But I've never done these motherboard repairs. I want to start doing it. I got this for cheapness. So I want to try to get it try to get it to work. So let me move on here, and I also have another one of these switches that works. It just doesn't connect to the TV dock. So I'm wondering what that might be. If you guys know what that could be, leave me a comment in the description. I'll be doing a video on that. I'm going to do videos on all these switches, any kind of fixes I do to them. I'm going to be making a video raw, unedited, just my learning process of this, because, you know, I'm going to try to refurbish these, make them look good, and, you know, try to make a little bit of money on them. I didn't pay much for this, so there's a little bit room for making some money, as long as I don't have to go down a huge rabbit hole of fixing too many things. You know, if it's just, you know, a couple of chips, it's not that bad. You know, it's not that bad if it's just a couple chips. But if it's, you know, maybe resetting this USB-C, you know, if that gets it to work, I'll put a new digitizer on it. And let me show you what I got going on for the rest of this. Let me go that off. Let me show you what's going on for this, what this stuff looks like. So if you saw the last video, I had to drill out a screw here. Let me lighten this image up a little bit. I had to drill out this screw right here because it was stripped from being opened so many times. So these screws have seen some wear and tear. They are, you know, on the cusp of going in one last time and not coming out. So I'm going to replace the screws, and other than that, this part, the front, you know, looks good, other than, you know, it has some scratches on there. As you can see, it has a scratch here that's pretty deep, and here. All the other stuff seems minor. I'm actually I come from a scale model background, and I have been able to buff a perfectly clear shine on a canopy. So I'm going to try, because I'm going to replace this digitizer anyways. So I'm going to try to buff out this and see what it looks like. If I get this switch to work, I am going to keep it and use it as a known good switch. So that way, if I need to check component values or things like that, I have a known working switch to check that off of. I wasn't happy with the seller not telling me. First, he said it wasn't opened, that nobody's ever been in it, and I was like, okay, cool. And I got it, and you know, it looked like someone had a go at the screws, but I was like, okay, maybe not. And then I started taking it apart. It was missing a screw, and then the strip screws, and then some of the screws were just so rammed in there. And then I opened it up, and it didn't even have a factory battery in it. Had this aftermarket battery, which seems to be in good condition. I have to do some capacity test on it, but it seems to be in good condition. And then I saw all the flux on the board. You know, the water intrusion sticker is just been soaked in flux. But you know, it seems like they took care. They put new thermal paste on it, so that was good. There was new thermal paste. You know, everything was clean inside, so nothing to really worry about there. You know, the metal casing is in good case, no bends, nothing like that. And then the back case is a train wreck. So the back case is all scratched up. I'll replace this. I have replacement cases. So I'll just, if I sell this, I'll replace this back case. If I keep it as a known working switch, I'm not going to replace anything but what it takes to make it work. So, and then, you know, I have a known working switch that's, you know, $80. Because, you know, I sent the seller a message and like saying, you know, I paid $100 for this. You said it was never opened. and he gave me $20 back. So I was I was just I wasn't looking for I still paid $100 for it, but this is the first time I'm fixing these to sell to make a profit in the turnaround, and I buy something that's supposed to never been opened before, and the first one I buy for this, the guy lied to me and it was opened previously. So that's where I am at this. So it ended up only 80 for this particular switch. So if I can get it to work, if I can suss out this battery management issue, maybe it's something there, maybe it's somewhere else. I'm gonna try to fix it. If I can get it working for the cost of a couple chips and gives me a known good working board to compare other switches to, then I think it's well worth the $80 just to have it. Maybe harvest it for parts another time, or just save it as a donor board. From what I can tell, I put a known good motherboard in there. The screen works, everything seems to work. It's just something wrong with the motherboard. So, I might use that stuff for a test housing, a test unit, just to test things and make sure everything works. And then, if hopefully I can get this to work and do that, because like I said, I have another one of these that I'm looking to turn around that just has some issues with the HDMI out part. It doesn't want to connect to the TV dock, but he didn't try any other TV docks, so it could very well be the dock, and then it may be a dock repair, or I'll just turn around and make sure the switch is in good order, change the thermal paste, clean it up real good. Maybe if it's scratched up, change the digitizer, make it look like it's in good recondition, have it tested real good. My son's, he's 12, so he tests stuff. He'll play it, check the battery, all that good stuff, and then, we'll sell it, try to make a little profit off of it. So, I even have some, Joy-Cons that I got that have the joystick drift, and I got some joysticks in to swap out the joysticks on, so and so I can actually have controllers that I can sell these as a whole unit. I'm also looking at getting a lot of the actual official Nintendo chargers, not fake Nintendo chargers, but actual Nintendo chargers, to sell as a lot of the actual game console, the set of Joy-Cons, and a Nintendo charger, so you actually have a Switch that works and going. Because I was going to do docks and all the other stuff, but it seems that once you get all the stuff, and I don't want a whole lot of aftermarket stuff that cheap and could break. I want to sell a good high quality refurbishment of a Switch unit. So, and I want, my high quality work to stand out there. So I don't want to do any aftermarket stuff. So if I can get a good deal on like a lot of actual Nintendo chargers, then I will do that, and then I will ship one of those with the units. I may, make a little bit less money on the unit, but I think it's worth it to sell them a working unit. And I'll specify that it comes with that, so it's a fully fledged, ready to go unit. But I am going to pause it here. I've been rambling for about 20 minutes about this, and we haven't done much on the board. So I am going to get prepared to yank this capacitor and check it out of circuit. If someone has a good known board and this capacitor ends up bad, I'm going to need to know the value of it. So if I pull this and the capacitor is bad, I'm going to need to know the value of that capacitor to replace it, because I don't have one to compare it to. So if someone, if I post this video and I haven't, and that was the problem, I'm going to need someone to tell me what the value of that capacitor is. I have 805 capacitors, so I don't know what value it is, and if it's bad, I'm not going to be able to tell. So, and I don't have a donor board, so or a known working good board to check components. That's why if I can get this to work, I will keep it as a known good working board to check components like that, to pull them off, to check their value, to replace them, so I know what readings are supposed to be, what diode readings are supposed to be, and things like that, so I can diagnose future boards. So that's my goal with this. So I'm gonna check this capacitor, and I'll be back. I'm gonna pull it off, and I'll check it live with you guys. All right. Okay, guys, I have the fume extractor on. I'm hoping it's not too loud. I switched to a headset microphone. I am got my hot tweezers. Hopefully you can see the hot tweezers here, right here. I am about to turn them on. These are a very cheap set of hot tweezers. I'm just starting out with them, so I'm going to turn it on. It's going to be set to 350. I'm hoping that there's some leaded on here, so the fume extractor is on, so we're going to let that heat up to 316. Let's do this, 350. 350C. So I'll put that down there, get the fume extractor up, and let's see here. Let's see if I can pop this cap off of here. Okay. I'm going to move that light, and I'm going to get me some of my pop-in flux, not that stuff. You know what, we're going to try this Amtech stuff because everybody raves about it, and I haven't been a fan. So, let's see if I can, let me tin my tips here. Some related solder. This capacitor is down there. Don't want to get that connector. Yeah, I don't know why he's not wanting to come off. Let me just crank up my temperature a little bit. I don't pull a lot of lead-free solder off boards. I am making a mess of this, let me tell you that. That capacitor, for some odd reason, is not wanting to pull off with my hot tweezers. So key does not want to come off. And tech flux. I'm going to heat up my soldering station. See if I can knock the guy off with that. Now let me try that I loosen it up here. I have never seen this happen before. Only on a video. There it goes. All right. Well, I'm pretty sure if it wasn't bad before, it's bad now. Doesn't look like I did any damage. Let's clean up the area here. I use MG Chemicals Flux Remover because I don't do a whole lot of this, so it's cost effective at that point there. Connector seems fine. Doesn't appear that I pulled any pads or moved anything else. So I would have used hot air, but I was afraid of doing something to that connector. So I just, I don't do motherboard repair, so I'm just trying to do this here safe and effectively. So I figured the tweezers would be the best. This is not the best viewing for this capacitor. Let me put it on the back of this. Okay, so there it is. Let's get some more light on it. Let's take a look at that grimy thing. Alright. Now, I want to check the resistance of it again out of circuit. I would use my LCR. It is nice that this saves my last setting. Of course, trying to hold down one end of this capacitor without touching any of the pads. Yeah, see, I'm getting two ohms on this capacitor. Let's check it on. Let's check the capacitance of it and see what that is. It's giving me about 992.5 nanofarads. Again, with that 2 ohm ESR, I don't know if that's supposed to be correct. So if you guys know that that is correct, I will slap that component back on there. So I am just going to, I don't have any 805s. I don't think, what is that, 1,000 nanofarad. Let me just, let me pop this off for a second. Let me get reorganized here and I'll be back in a second. Okay guys, this is how I started with replacing surface mount chips. I bought one of these Interstellar Electronics SMD Professional Assortment Kit. It comes with 1206, 805, and 603 components. It comes with resistors, capacitors, diodes. It doesn't look like it has an 805,000 nanofarad. Oh. I wonder if 1,000 nanofarad is 1 microfarad. I think it is. So let's just see, a 1 microfarad. I do have a 1 microfarad. We'll just see what that means. 805 capacitors. That's 1206. 805 caps. Let's just find that 1 microfarad capacitor and see what its ESR is. So we got 10 pico, 47 pico, 1 pico, nano, pico. There's only 1 microfarad, nano. Wait a minute, hold on a second, let me just, there's 1 microfarad right there. But I think I measured that wrong. I think it said 0.99 nanofarad. Let me just double check I hate to measure this thing again, but I just need to do it one more time just to be sure. Alright. I'm going to flip this over to this more grippy surface. Switch me to capacitor mode. And ping the chip. Yeah, 1 microfarad should be about the same reading, so I'm going to put this up there in my microscope view. So that's that. I'm going to pull up one of these 1 micros. I'm going to see if it's the same reading as that. Yeah, it's got a low ESR2 of 1.2 ohms. So this has got a... So I don't think it was the capacitor. Wow, this thing is a pain in the butt. I mean, it's got a slightly higher resistance than this other 1 microfarad, but if this truly is that capacitor, then I will, I'll put this back on, and I will note that on my notes that are not over there, that I know what that value of that is possibly. So it looks like that's good. I am going to double check it to make sure it's still good, but I believe it's still good, so I believe I'm going to put it back on the board and move on to checking the USB-C connector. I'm going to get reset back up to do that such thing. Alright, I'm back. I'm going to clean up those solder pads on there, and then I'm going to put this capacitor back. So I'm going to tin up my iron here, turn on my fume extractor. I don't want to get any more damage to my lungs. I'm just going to come in here and touch this a little bit of leaded solder to those pads. So I'm not going to use this Amtech stuff because I like to use the chip quick because it seems to hold my capacitor in place. Now let me get my good tweezers. All tweezers are supposed to be good. And let me put this capacitor down here. I'm probably going to butcher this. Not even on that pad. And it is on my finger. I'm going to need to come in here with the tweezers and turn those down a little bit. So I'm going to put a little bit more of this chip quick on there. And hopefully I'm going to be able to sit this capacitor down on there correctly. I think that is as good as I'm gonna get on there. So we'll check to make sure it's not shorted. So we'll put the tweezers up. I want to clean that area up with some I go through a lot of Q-tips. Might need to reflow this with hot air. That shit that is riding pretty high on top of there. Let's see here. Yeah, that's not quite down there. It's not quite sitting down on the pad there. So I'm going to have to reflow that probably with hot air. So yeah, that's just not sitting where I want to sit it. So far, I'm not a huge fan of these hot tweezers. I'm going to try again with them real quick. And a little bit more flux. I'm having some issues today. Got it stuck down now. There we go. Feel more confident with that. So, it's still hopped up. Yeah, that's gonna have to do for now. We'll test it in circuit. So this connector's still good. The connector didn't get melted no it didn't. It's still good. So alright, so I'm gonna give that a test in circuit. Man, that looks like garbage. I'm going to try to fix that with hot air without trying to melt that connector. So I'm going to do that. I'm going to do that off camera because it's kind of difficult to do the hot air on camera and try to get this right because it's my nerves are a little crazy doing this on camera. I've done a few of these, not motherboard repair, but fixing other things off camera. And I was like, oh, I could probably do this on camera, share it with you guys, but I'm getting a little shaky, so maybe it's blood sugar, I'm not sure. So I am going to try to set this capacitor down a little bit lower and see what's going on with that, with some hot air, reflow that. I may wait to check to make sure this battery management chip is good, and then I can just reflow both at the same time if I have to pull that IC. So the tweezers are new. I'm used to using hot air, but the tweezers are recommended for starting out, and it doesn't seem to. I don't know. They don't seem to heat the pads or whatnot really well. Maybe they're for bigger components like 1206s or something. I'm not sure, but the 805 it doesn't seem to want to really do anything about. So I'm gonna call it on this video. This video is probably about 30 minutes long. I want to keep these short, and I will come back to it. It wasn't that capacitor. The capacitor was good. Replaced it anyways. And then I marked it on my schematic that I'm building that it is 1 microfarad. So I will continue to move forward. The next thing is going to be this charge port, to take a look at that. But I want to test it to see what the voltage is, and I'll do that in the next video. Here's the link to social media. You can support me on Patreon. Thank you so much, and have a fantastic day.